have, all right, 8 whole pieces, okay, and if 4 over 4 is 1, all right, and we then have 8 of those, all right, I'm not going to draw 8 of these little pies all decked out in horse, but if we have 8 holes, that means we're starting with at least 32 divided by 4, all right, we're starting with at least 32 over 4. Now again, we are just simply multiplying this denominator, all right, multiplying that denominator. Yeah, go ahead.
What's the purpose of this class?
The purpose of this class would be, Mr. Higgins, long term is hopefully, as you guys prepare for college, all right, you have certain options that you can go into when you take your, dare I say, your prerequisite or your college required math class, okay?
Calm down, Quamaine.
Say it again.
He's talking to Josh. That's his name.
Alright. So, no, Higgins, listen. So, you can either go in, like say for, I'll use JCTC as an example, alright? Same thing probably applies, definitely applies at U of L, Thorne. So you have a math class that is almost like equivalent to a pre-algebra class, all right, and then you'll have what they have like a college algebra, and then you can either go into say a either a pre-cal, calculus, or maybe like a business math class. One of those classes, all right, one of those latter 2 classes will be what we call required, all right, but the pre-algebra type class, all right, it's not a requirement, but it is more like a prerequisite for you to take one of the next classes that I was talking about, either that college algebra and so on. If you do not have the skills that are in this class, all right, you would not be able to take that college algebra class, and therefore you would be have to take the pre-algebra class, pay for it, and it won't even go on your college transcript, okay? So this class will prepare you for everything that you need to test out of taking that class that you have to say quote unquote pay for. The pre-algebra class, I believe at JCTC it's like Math 061, whereas your college algebra class would be like a Math 150. At U of L they use a couple of different numbers, but the process is still the same. Alright, so this class prepares you for that test, which you guys can take as either before your senior year or at the end of your senior year. So I know some of you all are juniors. So this class suffices that. And so a lot of times you will take what we call the Coyote. It's Kyote. Take that test generally, like I said, when we're in the building. Ms. Baker gives it to you guys. I believe it has roughly around 31 questions, and you need to get 22 of them correct to pass. If you pass it, you become what is called, I want to say, college and career ready for math. Alright? And for the most part, I would say most of you all should be able to pass that wonderful test. The only problem is, a lot of times that we've seen in the past is we take the test for granted and we don't. We get 20 questions right, we get 19 questions right, or something like that. So what we're trying to do here is prepare you with every single skill possible, including fractions, so you can easily pass that test and go on into college and be successful without having to pay for it.
How do I pay tax?
I'm not understanding your question, Mr. Higgins.
I mean, you said prepares for every skill you need, man. I'm like,
You take a math test? Yeah.
okay.
Alright. So, alright, let's go back to our mixed numbers and then convert that into an improper fraction. All right. So let's look at again 8 3/4. All right. We got 8 3/4. If we take our denominator, which is 4, all right, and we're going to multiply it by the whole number. Mr. Harris has already told us that's going to give us 32 over 4, all right, and that is again just the denominator times our whole number, all right. I'm sure Mr. Harris would tell us also if we're looking at say a number line here.
Yeah.
Right? If we're looking at a number line, what is 4 times 9, Mr. Harris?
36.
36, right, alright. So, if we have 36 over 4 over here, 32 over 4 over here, and on a number line, we can look at that as, you know, say 8 and 9.
Yeah.
But, as you can tell, our mixed number here is 8 and 3/4. 8 and 3/4. So,
Are you writing this down somewhere? Because I don't see it on the whiteboard.
oh, really? My bad.
Well, I mean, maybe I'm just like, because I have to like click and drag. Oh, okay, never mind. I see it now. It's further down.
Alright, cool. Alright, so if we think of it, again, it's just breaking this up. Alright, we would get, you know, 33 over 4 here. 34 over 4. Oops, my bad. Over 4. And then 35 over 4. Alright. Just think of like a ruler, alright? How it breaks it up into like little small increments. Alright? So we have the two whole numbers, 8 and 9, 32 divided by 4, and then 36 divided by 4. But we have the whole fraction, remember that it is, again, 8 and 3/4. 8 and 3/4. So now that we have 32/4, if we just add the 3/4 to it, alright? Okay, so we now have basically 32 over 4 plus 3 over 4. We're going to end up with 32 plus 3, which will give us 35 over 4. Okay? 35 over 4. Right there. So, to figure out how to get from a mixed number, which has a whole number and a fraction, alright, to an improper fraction. Improper fraction, again, is a number whose numerator is bigger than its denominator. Alright? We're going to multiply our original denominator times the whole number, and then just add that remaining fraction to it. Okay? Add that remaining fraction to it. So in this case here, we are... Alright, we are just again 8 3/4. We are again 4 times 8 plus 3 all over 4. Okay? So, talked about PEMDAS and all that stuff last week and so on. This is kind of one of the places where it comes into play here. Alright? You got your parentheses, you got your 4 times 8, that gives you your 32. You add your 3, gives you 35. All over 4, you have 35 points. Alright? So again, going forward, it'd be nice if you go back and forth between these and be able to understand what a mixed number is as an improper fraction, and then also understand what an improper fraction is as a mixed number. Alright? And again, the opposite of that would be, again, if I'm looking at 35 over 4, alright, now you're almost going back again, Mr. Higgins, to your pre-algebra skills. How many times does 4 go into 35? You ask yourself that. As Mr. Harris has already told us, that's 8. Alright, how much do I have left over? 3. Alright, and so, you remember way back in, dare I say, what, 5 years ago for some of you all?
Well, like 6th grade?
Maybe. Was it 6th grade when you wrote it like that? 8, remainder 3, something like that?
I was like 5th grade. I was like
Really?
7 years, yeah.
Man, well, see, for me, that would have been the 70s. So, that being said, we don't write 8R3 anymore, okay? But that remainder does play, okay? Right, that lets us know that we're not at quite 9, the whole number 9 yet. We are 8 wholes with 3 out of what? Out of that original denominator. Alright, so since we start with force, we're going to keep it as force. So, how many times is 8, or how many times is 4 going to 35? 8. We have our remainder of a 3, and then 3 out of what? 3 out of 4. Alright, whatever that original denominator is. Alright, so you want to be able to kind of go, like I said, back and forth between them. Alright, now, Mr. Higgins, on your test, is it going to be this simple for your coyote? Probably not, no. A lot of times they'll put in variables, and then they'll also put in operations with mixed numbers, improper fractions, and so on. Alright?
Yeah.
Alright, so let's look at one like you may see. You may see something to the effect of, we'll stick with 8 3/4. Say 8 3/4 divided by, let's say 6/7. Alright. 8 3/4 divided by 6/7. So again, what they're doing is they're going to be testing multiple skills here. All right. Do you know how to divide by a fraction? You should. What do you do? Does anybody know? How do you
Divide by a fraction? Don't you just multiply?
Multiply what?
Like the denominator?
What's that word? Yeah, that's close enough for me. Yeah, sure. All right. Not the denominator, but what's it called?
The numerator?
There you go. Kind of a little bit of both. Reciprocal. Can you see that, Harris?
Oh yeah, it's when you take it upside down. Yeah, I know what the reciprocal is. Okay.
There you go. Good. All right. So again, upside down, or I think we used the word interchange the other day. All right. We interchange our numerator and denominator. So first, we would like to take that 8 3/4 and make it into an improper fraction. So 4 times 8, 32 plus 3, all over 4 gives us 35/4. When we divide by a fraction, we would like to change it into a multiplication problem. So it's going to be 35/4 times, and then we're going to interchange our numerator and denominator, which means we're going to switch them. A lot of people say flip it, all right, which means the 7 now becomes numerator and the 6 becomes the denominator. And again, we only do this with the fraction that we are dividing by, okay, dividing by. So now we have what we call a 7 over 6 here. Alright, we now have a 7 over 6. And then we're able, from there, to do what? Multiply straight across. Numerator times numerator, denominator times denominator.
Yep.
So without a calculator, 7 times 30 is what, 210, 35, so we get something like 245, all over 24. Then you ask yourself, how many times does 24 go into 245?
6? I mean, 8?
Man.
8 or 9, one of those two. I mean, I'm doing it off my dome. It's kind of difficult, but it's 8 or 9.
Keep going.
10?
Hey, you know you add the 0, you know, the 24, when you multiply by 10?
Oh. Yeah, but you said 20. How much did you say it goes into? Not 10, but like the 24 divided by what? I mean, what divided by 24?
245 divided by 24.
Oh, I thought you said 225.
No, not 225.
That's why I said 9, because I thought you said 25.
No, I get you. I got it now. You're fine. So then you ask yourself from there, what's that remainder? It would be a 5. And 5 doesn't go into 24, so we are simply 10 and 5 24s. Another skill, Mr. Higgins, for this. One of the things about that wonderful coyote test is that they ask you all kinds of questions that you may know how to solve a good part of it. All right, but you have to make sure that you actually answer the question that they're asking, or know how to recognize it. All right, because they may not give you the 10 and 5 24s, or they may not give you the 245 over 24. They may give you one or the other. They may give you both and then ask you which answer is not correct. You know, it's things like that. So you got to be able to recognize and be able to quote unquote kind of check yourself, all right, as you're going along. Which again is good mathematical practice, all right. Just keep checking yourself. All right. All right. So again, that is a few operations there with our fractions and our mixed numbers. I do believe that your assignment, your operation with fractions, is not that difficult, where you'll have to go back and forth. All right. And if you're able to, please show your work. I can tell by some of you all that have turned some of it in that you are capable of showing your work, but I need you to turn in the shown work. I do appreciate all the pictures I've gotten as well of work, that is.
Well, so I did it on like a PDF file, right? And it was like, it said basically that it saved, but then when I clicked on it again, it didn't save, and then I clicked on it again and it saved. So I didn't know if it would, like, what would happen. So just in case, I sent you pictures.
Yeah, I was gonna say I appreciate the pictures because I don't think I got some blank documents, or I even got a lot of times I just get the document that I send out. So again, make sure that when you are editing or whatever it is that you feel like you're doing, make sure that you're able to save it and then upload it and then submit it. Not just, again, return the document back to me, because that's frustrating. Very, very frustrating. Let's see here. Alright, give me a second. Alright. Now again, I know I'm not the best chalkboard, best writer on the chalkboard, so again, to express that mixed number as that improper fraction, what do you want to do? You want to multiply again, whole number by the denominator, add that remainder, add that numerator, alright, and then write it as the sum over the denominator, alright, write it as the sum, again. Let's see, Mr. Higgins, do you know what the definition of a quotient is?
It's like to divide it.
Do you know the definition of a quotient?
Oh yeah, quotient, man. It's just like it's like the answer, right?
Oh, that's awesome. That is exactly right, man. Good job. All right. So again, one of the things is recognizing terminology. All right. Sum, the answer to an addition problem. Difference, answer to a subtraction problem. Product.
I'm upset.
What's that?
I'm upset.
Why?
Not like with this class, just in general.
Alright, we'll talk about that in 17 minutes. Alright, so, again, product, answer to a multiplication problem, quotient, answer to a division problem. So, a lot of times you'll see that terminology there, alright?
That's rough.
Find the quotient of, say, again, these two improper fractions, or find the product of this. So, again, kind of just reiterating some of the skills that, again, you may have brushed over or maybe lost in those last couple of years. One thing about that coyote test is I don't think there's any geometry on it. Alright? So it's going to be all mostly algebra computations. Alright? Algebra computations. So anything from, dare I say, pre-algebra all the way up to probably the first semester of Algebra 2. No, it'll maybe deal with a little bit more than that. I think they do get into some quadratics with x squares and factoring and so on. But we, as a class, will not venture into that until after Christmas. But hopefully I get to see you guys. So, I mean, maybe. You never know. Alright, so, again, in a nice pretty form, what's it look like? Since we're talking about halves, alright, the green two, alright, it's going to be 2 times 2 plus the remainder, all over again, the green 2
That's
again.
rough.
You always keep the original denominator, alright? Taking notes today, write that down. Always keep the original denominator. Always, always, always. Alright. Now again, going backwards, this is again what I talked about earlier as well. Going backwards, alright, you're going to divide and then ask yourself what that leftover part is. Alright. Again, we don't say, ooh, in this case we wouldn't say, oh, 3 goes to the A 2 times, and then we wouldn't write 2R2. Alright, we're going to write 2 as a whole number, the number of times the 3 goes in there, and then that remainder of 2 is going to be our new numerator. Again, all over what? The original denominator. Alright. And from there, I do expect you to be able to go back and forth and then perform operations with fractions accordingly. Alright? So again, if you have that mixed number, please, please, please be able to go back and forth 3 1/5 to 16/5, 16/5 to 3 1/5. Alright. Alright, any questions so far?
Nope.
Awesome. Alright. Another example again, just so you can look at it. Again, for me personally, I would not write my 5 smaller than my fraction. I would write my 5 really big to let me know that I have that big old whole number, and then I have that small fraction as just part of a whole. But hey, to each their own. When you guys are hopefully showing your work, I do not need this middle step here. 5 times 9 plus 8. Alright, I do not need that step, but I would like to see the 53 ninths out before you start doing your operations. Alright, again, please do not spawn answers. Alright, I'm getting a lot of spawning. Alright, again, whole numbers, not so much of a problem. Again, you're going to just divide. Remember that all whole numbers also, if they're just represented by themselves, like the whole number 8, it could also be 8 over 1, 4 over 1. Remember 4 could be your denominator, so when you're dividing by those, think of, again, dividing something by 2 is equivalent to multiplying it by a half, 1 over 2. Remember the wonderful example I gave you the other day? What $1 divided by 2? What is $1 times 1/2? They should be equal.
So what is $1 times 1/2?
Yeah, what's half of $1?
50 cents.
There you go. Okay, so what's $1 divided by 2? Into 2 equal halves, 50 cents. So, alright, we talked about this as well. Going forward, multiplying. Do not get it confused. Please do not apply your multiplication of fractions with your addition of fractions. Multiplying, yes, you will multiply numerators by numerators and denominators by denominators, and then simplify if necessary. But when you add, please don't add denominators. Please, please, please. Oh, another thing, Mr. Higgins, probably the first problem that they ask you to add a fraction, the first problem they ask you to add a fraction on, I'm probably guaranteeing you the answer A in a multiple choice question is going to be whatever the two denominators are added together. So like if we were adding 7/8 and 4/9 instead of multiplying, if we were adding those, the first answer in that would be 11/17. Alright? And the reason why is because your brain, alright, is going to just be looking at those and may not be looking at numbers and not looking at your operation. Alright? Looking at your operation. Alright, so one other quicker way sometimes, especially like for the one in the bottom right here, is to simplify before you multiply. Alright? All the rest of these first three boxes are all what we call relatively prime numbers to each other. None of these numbers really go into each other. You know, 7, 1, 9, and 2.
Baby.
There's nothing that simplifies there. Alright. As opposed to
That's what I like to call fragging in my math class, boys. Let's go. 8 and 2 with like 10 assists. Fucking popping off, boys. Fucking popping off.
Feel free to mute yourself, man.
Wait, what fraction?